researcher at Optimum AI. And for the next 3 days, the agenda of the session would be like today at the day one, we'll be taught about the basics of like Numpy, Pandas, and Matplotlib library, which are the most commonly used libraries in data science and machine learning and Gen AI. And tomorrow we'll cover introduction to machine learning and all the classical ML algorithms. And the day after tomorrow, we'll start with introduction to neural networks and reinforcement learning. So I'll start the session now. I hope I'm audible to everyone. Am I? Can someone confirm?
Yeah, yes, you are audible.
Thank you. So starting with the introduction to NumPy. So NumPy is the most commonly used Python library for performing mathematical operations and computations, and it is widely used in ML and Gen AI. So it is one of the base. It forms the foundation of machine learning. So before we even move to algorithms, we need to be very clear with the usage of all the basic libraries. Now, this NumPy library allows you to play with matrices and vectors. And what we'll be covering in today's lab is how do we create a NumPy array and how do we perform operations on the array, like indexing and slicing, and how do we perform the basic mathematical operations, how do we perform statistical operations. So now, before like even start creating an array, we first need to understand like what is an array. So an array can either be a vector or a matrix. So suppose a one-dimensional array is termed as a vector, and matrix is basically a two-dimensional array. And it's basically used as a form of storing the data. And since ML is all about how do we manipulate the data, how do we understand the data and perform and build our models well, so it forms a crucial aspect of machine learning. So how do we even start? So if anybody is from laptop, he or she can code along with. So in order to start using NumPy, we first need to install it. But since I'm using Google Colab, it is by default installed in Google Colab. So in just to start using it, all we need to do is we need to type import NumPy as NP. NP is the most commonly used alias for importing the NumPy library or the module. So once I run this, we'll be able to import the NumPy library and we'll use NP to access or to perform the further operations. Now, once it gets imported, how do we create our first one-dimensional array? So one-dimensional array only consists of a single row, whereas a two-dimensional array is a combination of rows and columns. So in order to create a one-dimensional array, there is a method in NumPy, which is dot array method. Herein, you need to pass a list, and the list can contain any number. So if you pass a list, for example, in this example, I'm passing a list of 5 numbers and I'm using this np.array function. And now if I print this a element, it will print this. Now this, if you print the type of this a variable, you'll see it's n-dimensional array, NumPy array. So basically, just using np.array, it allows you to create a NumPy array, and the type of the array which we create is ND array. ND array basically stands for n-dimensional array. If you want to know what is the shape of the array, or basically in case of 1D array or vector, the shape is defined by the length of the array. So we just simply use the function like shape, and we can do the variable name dot shape, and we'll get the length of the array. So in this case, I have 5 elements, so the shape will print 5. Now, in order to create a 2D array, or what we more commonly call as matrix, we simply give a list, and the list can contain tuples, so multiple tuples. In my case, I've given one tuple which contains five numbers and another tuple which contains five numbers. So if I use this np.array function, what it will do is, if I print it, if I store it in a variable, it will create a matrix that will have five columns and two rows. And if you print again the type of this, you'll see it's again a ND array object type, and the shape. You print the shape. What shape will return to you is the number of rows and the number of columns. In our case, if we can see there are two rows, row one and row two, and there are five columns. So I hope I'm making sense till here, till now. So we started with very basics. Now, further continuing, we can create an array from a list. So, suppose if we use Python and we most commonly deal with lists. So, for example, we have a list, we have an existing list, and you want to convert it into an array. So, how can we do that? We simply again need to use np.array, and we need to pass on the list. So here I have this existing list which has few elements, and inside this np.array function, I'm just passing my list. If I pass this, it will create again an array, numpy array, and if you can verify this whether the array is created or not by printing the type. If you print the type, you see it prints numpy.nd array class. Now we covered how do we how can we create an array, but NumPy offers various ways in which we can create an array which already consists of numbers. So what we can do is we can create different kinds of array. For example, you can create an array which just consists of zeros, or which consists of ones, or which consists of some numbers within a specified range, or some random values. We can even create an identity array. So I'll walk you through all the functions or methods which are used to create such kind of arrays. And we do widely use this. We need to create arrays sometimes. For example, if we in machine learning, if we perform like one hot encoding, or if we convert the categorical data into a numerical data, in that case we need to like generate an array which consists of ones or zeros. So this is how like what the practical implementation of these functions in the real life scenarios. So the very first is, how do we create an identity array? So before we even generate an identity array, what do we mean by identity arrays? If you all must have studied in maths, or even if not, any array which has all the principal diagonal elements as one is termed as an identity array. All the numbers which all the principal diagonal numbers are one, and rest all the numbers are zero. So in order, here's this example of an identity array. So how do we create it? So it's just simple. You need to use dot identity function. So there's an identity function in NumPy, and you need to simply pass in the number, like how many rows or columns do you want. So by default, it has equal number of rows and columns, and like it is like identity matrix can only exist in case of matrices which has like equal number of rows and columns. If you specify five and you print this, you see there are five rows, one, two, three, four, and five. There are five columns. If you change this number to three, what will happen is it will create an identity array which only consists of three rows and three columns. There's again another method to create an identity array, which is using .i function. So here you just need to type np.i, and you just give the size. Like you want four rows and four columns, you just give four, and it will generate an identity matrix of like ones. If we want that, suppose if we want that instead of one, we want this number to be some particular number, some constant like 7 or 16. So what we can simply do is we can multiply by a constant. What it does is that it multiplies each and every element of the matrix with this number. So for example, here it was 1. So 1 multiplied by 7 gives us 7, right? And 0 multiplied by 7 gives us 0. So it does multiply all the elements by this constant, and you get element wise multiplication result if you use this multiplication operator. If you do it by 16, you will see you get 16 everywhere. Now we saw how can we create an identity array. We can also create an array which only consists of zeros. So we do need this when we want to create some sparse matrix. We need a combination of zeros and ones. So to create a zero array, like array which consists wholly of zeros, we can simply use np.zeros function. And you can again give the number of like elements you want. If you give only one number, what it does is it creates a one-dimensional array. So it will create a one-dimensional array which has say 5 elements in this case. If you change it to 10, it will create a one-dimensional array which has 10 zeros within it. And if you want to create a two-dimensional array, you need to basically pass a tuple, and it will consist the first number will signify the number of rows, and the second would signify the number of columns. For example, if I do np.zeros, I see the first number is the number of rows. The array which will create will have 2 rows, and the second number is the number of columns. So it has 3 columns, 1, 2, and 3. I can again change it. Suppose if I want an array which has 5 rows and 8 columns, I can just simply change the numbers, and you see it has created an array which is 5 rows and 8 columns. Now, coming to generating an array which has only ones. So again, like similar to zeros, we used np.zeros function. To create an array which has only ones, we need to use np.ones function. And by default, it takes one number and like it will create a one-dimensional array. And in order to create a two-dimensional array, you need to pass in the tuple. So you can try this on your own. At the end, I'll also be sharing the link to this notebook so you can go through it in detail. Now coming to generating an array in a given range or interval. So suppose if for your problem statement or for some reason you want to generate an array, and that array should only consist of numbers between some specified range. So how can you do that? So in NumPy, there's this, it can be created very simply. You just need to use this arrange function. And what it does it takes your starting point, like from where your number should start, and it takes your ending index, like where should your number like ending range, like ending interval. For example, if you want to generate an array which only consists of numbers from 0 to 5, so you can just use this function, it will generate an array. And the last number is not inclusive, like it is exclusive. You'll not see 5 here, it ends at 4. If you do 0 to 10, it will create an array which consists of all numbers from 0 to 9. And 10 is again, like I said, it's exclusive, ending number is not included. Now here you saw that the numbers which are generated have a difference of 1 between them, right? What if you want to create an array and it should have like the elements should have a difference of 2? So how can you do that? So you can simply pass in your range. The first two numbers will specify your range, and then you can give the step size. So what is the step size? If you want an array which consists of elements that have a difference of 2, for example, I want to generate all numbers from 0 to 20, and it should be like the difference should be of 2. So you see, I get all the even numbers between the range 0 and 20, 20 not inclusive. So that is how you create an array, and you can specify the step size. If you specify it 5, you'll see it will create an array which has a difference of 5. elements with a difference of 5, like 0, 5, 10, and 15. There's another method similar to arrange in NumPy that allows you to create like evenly spaced numbers in a given range, but there's a small difference. So lens in if you use this method dot lens space, what it does allow you is that it will include both these elements. So in arrange method, you saw the last like the ending range is not included, whereas in lens space, the ending number is included in the array. So if you specify this, you see your array starts from 0 and ends at 20. But when you were using this arrange function, your array didn't included 20 here. That's the only difference, and everything is same. The starting point, the ending point, and the step size. So this is how you use the linspace method. Now, suppose if we want to generate an array that has some random numbers. So why do we need such array which has some random numbers? So in most of the probabilistic algorithms which make use of probability and are basically if we perform some probabilistic analysis, we like hugely deal with random numbers, and we need to generate some arrays which contains some random numbers to include randomization in the process. So in order to generate an array which consists of random numbers, what we do is we call the function np.random, and inside random there is again a function called rand, which allows you to create an array of random numbers. If you specify the number 4, like if you give the range, so it will create an array which consists of some random numbers, and like the range of these numbers is 0 to 1. So it will contain some random numbers between 0 to 1. And if I run this, you see I get some different values here. If I run it again, you'll see that the values are not same. The values differ. So this is how we use the random.rand function. We can also create a matrix using random.rand function like a 2D array. So we need to specify the number of rows and the number of columns. So in this case, the number of rows is 4 and the number of columns is 5. If I run this, just observe the numbers, they'll change again. If I execute this, they'll see the numbers have changed, and this array consists of 4 rows and 5 columns. Now, the numbers that this array consists are basic floating point numbers. They are not integers. So if like you want to generate an integer array, you can use dot rand int function, and what it does allow
एक
you is if you
वर्कशॉप
like
चलनी छोटी सी
simply
हम्म,
pass in the range. So it will generate
अभी
a random number between the range you have specified. So it will generate any random number between 5 and 50. So if I run this, you see the number is 39 right now. If you again run this, you see we got 13. And if you again run this, we get some another number, see 15 here. If you want to generate like an array, what you can do is you can specify the number of integers you want. So by default, it returns only one integer. But if you want, suppose 10 integers and all within this range, you can simply give the range here. If you run this, you'll see it returns an array of array consisting of 10 elements. Now, coming to the next part, suppose if you want that whatever numbers which I get, you want to get the same number. Or suppose if you want to get a same random number every time you run your code. So for that, you have this seed method. So seed takes value from 0 to 40. And if you use this dot seed 10 in your collab notebook, if you give this range, you'll get this number. The number won't change. If I run this cell again, I'll again get 41. So in some cases, basically in research, there's sometimes requirement how do you verify research. So researchers use this dot seed so that their research results can be regenerated and it can be cross verified. So This is how we can generate random value, but that remains same in every run and it does not changes at runtime. So we covered the first part, like creating an array, and we covered the second part, how do we generate some existing arrays like which are offered by NumPy. Now, we lot of times what we have is we have a lot of data, but the entire data is not relevant to us, right? We want specified data or we want some section of data which is useful for our use case. So for that, we have a facility like we can do slicing or we can access the part of the array or the part of the data which is relevant to us. And there's another feature called indexing. So indexing basically means we can add labels to our data. For example, if you were in school, there's a roll number assigned to every student, right? So that is like you have been indexed with your roll number, and it's kinds of it serves as your identity, like anonymous identity. So indexing is also widely required. So indexing and slicing are the most common and most widely used operations to perform data selection. So we'll start how do we index and do slicing in the 1D array, and then we'll move to the 2D array. So does anyone has any doubt till here, or should I continue further, or have people slept?
No, all good.
Okay, thank you for confirming because it's one-sided and just feel lost sometimes. So coming to the indexing and selection part, how do we do indexing and selection in the array? So you create an array. Here I've created an array which consists of 5 elements. Now suppose if I want to access these elements, right? So by default, what happens is that Python, it starts your indexing from number 0, and it doesn't start from 1. The counting or the indexing starts from 0, and the first element, the element at the first position has the index 0, the element at the second position has the index 1, the element at the third position has the index 2. So suppose if you want to access out of these numbers only one number, like you want to access this 2, so how can you do that? You see the index for this number is 1, so you just simply type the name of the array, and you within the square brackets you type the index, that is 1 in this case. Once you type this, you can see you got the number got returned back to you. If you want to access suppose the number 4 in this array, so what you can do is you can give the index. So index in this case is 3. You type in, you see it will return you 4. Now Python, it allows you to index the numbers from front, as well as it allows you to access the numbers from back, or it allows negative indexing as well, which a lot of programming language do not offer. So what do I basically mean is the last number is labeled as -1, since you're accessing it from last, right? The second last is -2, and it goes on so on, -3. So suppose if you have a huge data set and it has some like 20,000, 30,000 rows, and if you want to access only the last row of the data, so how would you do that? Or you don't know the number of rows and you want to access some last rows of your data set. So we basically make the use of negative indexing. So if you type in like if you want to access the last element, which is 5 in this case, you just type in the array name and you give the negative index. So here you see it returned the last element. Now suppose if you don't want a particular number, but you want that all the numbers within this range should be returned to you. You want to access these 3 numbers out of this array. How can you do that? So for that, we perform slicing, right? And in slicing, you can give the starting range and the ending range. Again, to specify the start range or start index and end index, and the ending index is not inclusive. Like if you give the starting index as 2 and the ending index is 4, so what it will return you is, it will return you the numbers like that start from 2 and that ends at 3, not 4. In this case, if you use this, what you'll get is you'll get only two numbers. In this case, it's 3 and 4. If you see, the number 3 comes at the index 2 and number 4 comes at the index 3. So you get only these two numbers, and the number at the index 4, which is 5, is not returned because the last or the ending index is not inclusive. Similar to the way I did positive like indexing, I can make use of negative indexing as well to access say the last two elements. Both of them would give same results. The only difference is like I've used negative indexing in this case. So again, I'll get the same results, and you can like run this code in the notebook and cross verify and play with the numbers by yourself. Now, as we covered the index like selection or slicing of the 1D array or selecting a particular index of the 1D array, we'll now move on to indexing and selection of 2D arrays. So, how do we do that? Suppose if I have an array here, I have an array which is stored in the variable array underscore 2D, and if I print this array, so what I get this array which consists of three rows and three columns. Now, how does the indexing happens in this case? As I specified that in Python indexing starts from 0, right? So the first element is known as the element belonging to the 0th row and the 0th column. The second element is said to be belonging to 0th row and the first column. Similarly, third element is 0th row and the second column. So these are your rows, and this vertically like 1, 4, and 5, 1, 4, and 7. This is your first column. This like 0th column. This is your first column, and this is your second column. So if I want to access a particular element, suppose in this case, if I want to access the element 5, so how can I do that? I see the 5, number 5 is here. So it belongs to 0th row, first row, and it belongs to, this is the 0th column, and here it's the first column. This number basically comes in row 1 and column 1. So I'll simply access it by specifying row 1 and column 1. So if I do this, I can get 5 here. If I want to access 9, I can simply do second row and second column. So I get 9 here. Now suppose if you want to get a particular row, if you want to get this entire row, 0, 0, how can you do that? Instead of specifying the column, you just give in the row. If I want to only access the row, I only give the row. So I get access to the whole row here. So this is how you access particular numbers or a particular row from your matrix. Now suppose if you want to access a particular section, you have a huge matrix. In our case, we have only three columns and three rows. But if you have a huge matrix, say many number of columns and many number of rows, you want some particular section of that matrix to be returned. You want some rows and some columns. So in our case, suppose if we want all the elements or all the rows up to 2, again 2 is not inclusive, and you want all the columns. So basically, if I'm to specify you, if I write like this, and if I use comma to separate between rows and columns, and I use colon. So colon here tells the starting index of row, and this is your ending index of row. Similarly, here it's starting index of column and its ending index of column. ending index again is not inclusive. And so if we don't specify anything here, if we don't specify any starting or ending index, it assumes to be zero at the starting and the length of your matrix as the ending index by default. In this example, what I've done is I'm accessing the rows till index 2. So I'm accessing the 0th row and the first row. And since I've not specified any columns, so it does returns us all the columns. So if I run this and print it, you see I get the first two rows of my matrix and all the columns. If I specify the column, suppose if I only want two columns, the first and the second here. So I can do two here. If I print this, you see I get only two columns. So again, you can play with this more and then you can see what different results it uh, gives us. So I'll, these are like some examples which I've included and you can go through it in detail. I have a lot of content to cover. So I'll move on to the next section. These are like just examples. Now, what we'll do is we'll come to conditional selection section. So, what do we mean by this? Now you have your data set, but what you want is suppose if you want to access some values based on certain conditions. Suppose if you have a data set that has temperature data and you want to access all the rows which have temperature greater than, say, some threshold temperature, say greater than 35 degrees Celsius. So how can you do that? So like in our mathematics, we used to do make use of lesser than and greater than operators. Similarly, very similar to that, in NumPy, we can make use of these operators. So suppose if I have an array and this is how my array looks like. Now if I want to access all the elements in an array which are lesser than the number 6, right? So how can you do that? We can just simply type the array name and within square brackets we can give our condition. So it what it does it compares each number with the condition and it returns the numbers which satisfy this condition. For example, it will check whether 1 is lesser than 6. Yes, then it returns. It will check for each element. 2 is lesser than 6. If yes, it will return. So likewise, you see you get the numbers till 5 since they're lesser than 6. If you want the numbers greater than 6, you can simply use the greater than operator. If you want all the even numbers, so you can perform the modulo operation and you get all the numbers from your matrix, which on doing modulo operation with 2 will result in 0. So if you run this, the modulo operation is performed from each number and you see you only get the even numbers. If you want to access the odd numbers, you can simply use this condition. If on dividing by 2, we do not get the remainder as 0. Basically, those are odd numbers. Now, these are single conditions, but in case you want to have multiple conditions, so suppose if we want all odd numbers and we want numbers which are greater than or equal to 5, right? So we can specify these multiple conditions by using AND operator. So it will only return the result if we do an AND condition 1 and condition 2. So it will return the numbers which specify the both these conditions. Now, suppose in this case we got the result back, but if you want to do a logical selection, what do we mean by logical selection? If we want to check whether for the entire data, whether if we run this condition, it's true or false. So we want to check against each element. We want to check whether the number is greater than 5 or not. If it's greater than 5, it will return as true at those places. And if it is not, it will return as false. Suppose if you want to check whether a particular number belongs in this array or not. For example, if you see the array, we had the numbers from 1 to 9. We didn't had any 0. If you run this, if you use double equal to sign and check whether array has any number equal to 0, you get false. But if you check it again, say 9, and if you run this, you see at that place where the number 9 exists, you give true. Now, these were the operations which we performed using these logical operators. We can NumPy offers us functions to perform mathematical operations, basic mathematics, and even advanced mathematics and statistics operation. So those are addition, subtraction, multiplication, division, squaring. So like these are basics, and you can go to the documentation and find out more advanced arithmetic operations which it offers. So, for example, if we have two array, here I've taken two array, generated an array consisting of element like numbers within range 0 to 4 and here 6 to 10. And suppose if you want to add both these arrays, so we can simply do array 1 and we can use plus operator. We can do array plus array 2. What it will do is it will add this number with this number. Like the zeroth row of array 1 will be added to the zeroth column of array 1 will be added to zeroth column of array 2. Similarly, zeroth column of array 1 will be added to, first column of array 1 will be added to first column of array 2. You can see, like, check the results here. So 0 plus 6 gives us 6, 1 plus 7 gives us 8, 2 plus 8 gives us 10, 3 plus 9 gives us 12, and 4 plus 10 gives us 14. Now, like you did the subtract operation, you can, like you did the addition operation, you can even do subtraction. You just simply need to use the like minus sign or the subtraction sign. You can even do multiplication. So it again, it does subtract all the numbers from array 2 with array 1. If you multiply, you get the results of multiplication. If you divide, you get the results of division. If you want to square each element, like array 1 consists of numbers here. It has numbers 0, 1, 2, 3, and 4. If you want to square each individual element, like you want the square of 0, square of 1, square of 2, square of 3, and square of 4, you can simply use the uh, exponentiation property. Like it's basic Python, you just use double asterisk and the number 2 to do a squaring operation. So here you see, like we can perform this. Now, this for like we directly use the symbols, but there are universal functions like being offered by NumPy as well. So you can do the same what we were doing there using np.add function. Within add function, you give the array name. So here again, I've taken two arrays and I'm using np.add function to do the same thing which I did using plus operator. If you want to find a product, you use dot multiply function in NumPy. If you want to subtract, you use dot subtract method. If you want to do division, you use dot divide method. Now, if you want to get the sinusoidal value or the sine value of each number, we have np.sine function. So this is basically used like if we want to plot some curves or some data and we want to see the variations of the data or we want to see like how is the kind of data, and it's mostly used in real-time data uh, monitoring applications like in using in analyzing those data sets. So you can use cosine, you can calculate the cosine or cos function. We have this tan function as well, so we can use tan function. We can use log. We can find the log of each element using np.log. We can similarly find exponentiation. The exponentiation, you'll see it's used in logistic regression ML algorithm np.exp. It's used for some plotting some activation function graph and doing some computation. You can use power function. So this, what does this power function do is it it will return it will do the power of all the elements of array 1 with the elements of array 2. For example, you see the first element of array 1 was 0, so it will do 0 to the power 6, it will do 1 to the power 7, it will do 2 to the power 8. Like these are some mathematical operations, these greater than, lesser than. You can explore this in great detail. I'll share the notebook again. Now we can, what most widely used operations which we'll be performing with NumPy is performing the basic statistics. So we want to understand our data well. So for understanding the data, we need to know the mean value. We need to derive inferences. We need to know what is the median, what is the minimum value, what is the maximum value, what is the standard deviation, how is the data varying. So for that, NumPy offers very simple, ready-to-use functions. You just need to pass in your array to that functions, and it will compute and do the entire computation and return you the result. So if you have an array, you want to compute the standard deviation for that array. So standard deviation is how much the element deviates from the mean value of the array. So suppose if you have a data set that consists of ages of people and you want to see what is the mean age, you want to see how the data varies, like what is the range of the ages we have, like whether it's like 20 to 30, like we have the data of young people, or it's 20 to 50, like we have the data of young to old people. So you can do that using standard deviation. So np.std is the method. So it's quite simple. You just need to type in the name and it returns you the result. If you have 2D array, again you get a single value. But if you want to get standard deviation for each row, you can specify the axis. So if you specify axis 0, it does return for each column. And if you specify the axis 1, so if you use the axis 1, it returns for each row. Like for each row, it will compute the standard deviation. It will give you the result. So this is here. Now, variance is how the data is varying. Is the data widely spread, or is the data narrowed? Like we have the data within some specified range, and data is not varying much. It's data to the point. So we use dot var to compute the variance. So again, you can just try executing the cell. If you want to calculate the mean of the array, you use np.mean function. The mean is basically the average value. And see, here we have dot average method as well, and it will give the same result as mean is just same to average. Now you can compute median and you can find minimum, all the minimum number within all the numbers within in the array, the maximum, and so on. So this is we covered like mathematical and statistical operations. Now I think this is the last part. We can find the shape of the array, which I already told you, like using array dot shape method. So if we have this array, if you want to know the shape, in case of 1D array, it returns us the length of the array, which is 10 in this case, since it has 10 elements. In case of 2D array, it gives us number of rows and number of columns. Now, most widely used like thing when you're dealing with data is changing the shape or reshaping the array from one dimensional to two dimensional, or say from one dimension, like you want to reshape the array. So how can we do that? We have a reshape method which takes in the array name and takes in the new shape of the array, the new number of rows and columns. And another way to do is directly use the array name and dot reshape, and you give in the rows and columns. So in this case, suppose if I want this 1D array which has had like 10 elements, it was something like this. I want to reshape it to contain 5 rows and 2 columns. If I run this, you see it has 5 rows and 2 columns. Now here I'm using np.reshape, but I can directly use the array name and use the reshape method. So the n-dimensional like array, or if it's an numpy array, you have access to dot reshape method. So again, there are some few examples. Resize is same as reshape, and herein we can specify the size what we want, and you can like go through this in detail again. Now, how do we copy an array? How do we create a copy? If you have an array and if you want to copy it into some another array, you just simply use dot copy method. So I would end this session like for NumPy, I would end and I would move to the next library, which is Pandas. So I've covered all the basics of NumPy which you need to know in order to start your ML journey, or basically start playing with the data sets in real world. And as you move on, you can learn more things. And I have lot of content in this, and you can like go through this in detail and read or like this entire notebook and execute it. So that would be an assignment for you. Now, another powerful library which we widely use in data science and ML is Pandas. So, what does Pandas offer us is it allows you to uh, do data manipulation. It allows you to store your CSV or Excel data or tabular data in form of data frames, and we'll see what do we mean by data frames and series, and we'll see how do we perform indexing selection. Like it's very similar to the process we did in NumPy array, and we'll see how do we manipulate the data. So if there are repetitive things, I would just skip it, or I'll just take a faster look at it, and later you can go it in detail. Now, once we complete these basics of NumPy, which like pandas, which I'll go through how do we deal with missing data, how do we do indexing, selection, iteration, how do we perform basic aggregations or joining. I'll also show you an example of real world exploratory data analysis. So we'll use a real world data set and perform some exploratory data analysis on that. So if I start with data manipulation, so there are two terms which I used, which is series and data frames. Now, series is nothing but a one-dimensional NumPy array,
Uh,
which,
Jyoti,
uh,
are you sharing the
yes,
screen?
yeah,
It's
okay,
only
it
showing
was it not?
NumPy for data.
Oh, I'm so sorry. Is it visible now?
Yes,
And
Jyoti, go ahead.
okay, okay, really sorry, I just didn't notice. I hope you can see the topics which I'll cover for pandas. These are the topics, like the key topics to cover, and then a real world EDA problem statement. So if I start with what is series and data frames, so series is nothing. It's just a NumPy array. And what it does have is it has labels to your array. And a data frame is a multi-dimensional NumPy array with labels on rows and columns. You'll see what do I mean by labels within a while. So, again, in order to use pandas, you need to import it, import pandas as PD. PD is again like globally most widely used alias. So we'll start by creating a series host. So series can be created using anything like Python list or dictionary or NumPy array. So if I have a list and I use dot series method, which is offered by pandas, what I see here is it returns me these numbers, but what you also see is that on the left hand side, it has this number 0, 1, 2, 3, 4. So what it did was it indexed these, like it provided labels. So the first number has the label 0. Suppose if we want to give our custom labels, we don't want it to be 0, 1, 2, 3, 4, but we want to specify like what should be the label. We can do this using the index parameter, and we can pass in the index. Just make sure that your index list which you pass is of the same size or the same length as your list which you are creating series. So if I run this, what you observe is against Monday, like it's labeled as A, Tuesday is labeled as B, and this is what we get. One thing to notice is in case of numbers, you see it's of integer data type, but in case of string, right, Monday is a string, it's of object data type. So in pandas, strings are treated as object data type. Now, further continuing, suppose if you have like data, or say you have your country and the country code, right? So you can simply again like create a series which will have the country code as the labels and the country name as your data. So these are like few examples of series. Now we'll see how can we create a series for NumPy array. It's very same. You just have your array and you just pass in the array to the series method. And you can do similar things what we did for the list for the NumPy array. Nothing changes. It's very simple and similar. Now, we don't use series that often, but it is worth knowing it because series form the basis of data frame. So likewise, we studied series. It's a one-dimensional array. It deals with one-dimensional array and provides labels. Data frames, what they do is it deals with multi-dimensional array. And usually in the real world, when we deal with data, it will have many rows and many columns. So in this case, I've taken the names of the country and their code. So I have a Python dictionary which has the name of the countries and the codes as the key. And if I want to create a data frame, I use pd dot data frame method and I just simply pass on my dictionary, right? If you run this, what you observe here is you get a data frame and see how beautiful like it looks. So understanding this is difficult, but understanding this, what data is it, it's very simple. It's clearly presented in tabular format. So you see you have name and you have codes. So these are the labels which I was talking about. It's just a NumPy array, but it has these labels for the columns and this 0, 1, 2, 3 labels for your rows. If you want to create like you have an array and if you want to give the column names by yourself, you want to customize the column names or you want to change the column names, you have dot data frame method and you have a parameter called columns where you can specify the column names. If you run this, you see the first column is labeled as column 1, the second column is labeled as column 2, and the third column is labeled as column 3. So this is how do we create a data frame. Second, if suppose if you want to create a data frame from series, so that is even possible. So you can convert a series to data frame. So the first, what we are doing is we have this dictionary and we are creating a series. Then we are just simply passing this series to the data frame. And what we get in return is a data frame, which has this as your it has single row and single like it has multiple rows and single column and the column is labeled as codes and the rows are labeled with the name of the countries. Now to this data set, suppose if you want to add another column, so you want to add another column which tells you the population of each country. So you can like these are not realistic numbers, so just consider them for example. How you can add a column is simply just uh, type in your data frame. So we have stored the data frame in a df variable and you specify the name of the column within square brackets and then you pass on your list. So this list is basically the rows, like the value for each row. And you should again make sure that it has the same number of rows as in the existing data set, otherwise it's going to give you an error. You run this, you see we have a new column called population and we have all this data. So it is really simple playing with data or the data frames or data sets, adding columns, removing columns through pandas. It makes all this tedious tasks very easy for us. Now, suppose if we want to remove a column, so we added a column, but if you want to remove a specific column, maybe while we are performing data analysis, we found out that this column is not useful for building our model. So how do we remove that column from our data set? So we use the drop method and we specify the axis one. So like always remember axis 0 is for specifying if you want to remove a specific row and axis 1 signifies removing a particular column. So what it will do is it will remove the column which has column name as population. So run this, you see the population columns is gone. If you want to access the names of all the columns, so see this wasn't in place, like it will just return you back, but if you want it should happen for the real data frame, you need to use this in place is equals to true, but I'm not doing it right now, otherwise it will modify my original data frame. What we usually do is when we perform such dropping operations, we simply create a copy of our data frame so that we don't lose our original information. Now, if you want to access all the column names, you have dot columns method or method offered by this pandas data frame object. So you just do df dot columns and you see you have both the column names here. If you want, again, there is another method called keys. So if you run this, it will return you the row data. Yeah, if you do df.keys, it will return you the labels which we were using for the row. So these are basically the indices which I was using. So here you get these row names. So for accessing columns, you have dot columns, and for accessing row labels, you have dot index method. Now coming to again like performing data selection and indexing, we can simply like indexing. I already told you we can use index parameter. We can specify the indexes. Uh, like similar to what we did for columns, we specified the column names. We can specify the index as well, and we see it has um, given these indexes here for our data frame. Now, if you want to access, say, a particular column, what it will return is it will return that particular column as well as the index of the column. Now, suppose what you want is you want to create a uh, new column called country, and you want the name of the country to be capitalized. So you can simply access this name, like all the country names using name column, and you can pass in the column name, and you can use string dot upper method, and you can store this in a new column called country. And if you run this, you get a new column called country, and it has all the country names in capital. So, like these are small things which we'll be using quite often, or it's used quite often. I'll skip through this because it's again like very repetitive and I've already covered. Now, if you want to access, suppose only the first two rows, like I told you, we can in like we used to do in NumPy, right? We will just simply specify the starting range and the ending range, and ending range is again not inclusive, so we'll get the first two rows. So it's 0 and the first row. Similar to what we do here, we have dot loc and dot ilog functions. The dot log function, if you pass in your index, it will return you the data frame with having like it will return you the row which has this particular index. In our case, if you see the first row has this index A. It returned me the first row and all the column values, like it has USA1. It returned me that. If you want to access within some specified range, if you want to access all the rows between index B to D, you can just use this method and you can get all the indexes. Again, this like all the rows. Again, this is the same. Here you're not specifying the starting point. So what it will do is it will assume the starting to be 0 and the ending to be the index specified here. Now, ilog is similar to loc, and it does returns us the same. The difference lies is that here, if you observe in a log function, you were getting like the name and the data type as well. Here also, you're like it's just same, and it's ilog is more commonly used. It will allow you to access even rows and columns, and we'll see further how do we do this when we're using the real world data set. Now coming to conditional selection, similar to what we learned in NumPy, we can access our particular values from our data frame using these conditions. For example, I want to get the rows or the data where the country code is 49. Simply specify, I simply compare um, all the rows against the condition like which have the code as 49, it will return me that particular row. If I want all the country names or my entire data which has country code lesser than 250. If I run this, I'll get all the country information which have the code lesser than 250. So like these are again same, and I can again use AND operator to club multiple conditions. Other than this, there are two other operators which are isn't and where, and we quite use them a lot. So what this isn't offers us is, suppose if you have an existing array, right? You want to you want to see whether your data frame has the values that are present in this list. So you have this list and you use dot as a function, and it compares whether each of the element, like whether this value was present in our data frame and is it present in this list. If yes, it will return you true, and if not, it will return you false. So it's kind of logical selection, and it would make you more like it would make more sense when we'll be dealing with the real world data. So this is all same. I would skip through it fast. This is like comparison operator. Now, what where condition allows you, like whatever place this condition you satisfied, if it is getting satisfied, it will return you the number. But the places where this condition is not getting satisfied, it would replace by the second argument which you passed on. So in this case, it is 0. So wherever the data set has the value greater than 4, it will give you like that number, and in other places, it would return you 0. Now it's just same. Now iteration, I'll cover this in example. I have added this in this collab notebook so that you can go through it in detail in when you get the access to the notebook. But I'll come straight forward to how do we deal with missing data, and can go through this in detail. If it's wherever it will come, I'll explain it to you. So now dealing with missing data, the most common thing which we come across whenever we are using a real world data set, we have a lot of times where we don't have any data available or we have missing data. So how do we check whether our data frame has missing data? So suppose I created a data frame which has some missing values, and in order to have missing values, we use np.nan. So if any value is assigned nan value, it's just like your data is missing, similar to your missing data. So if you use dot is null function, what it does return is wherever the value is null or the data is missing, it will return you true. Here you see you get true at these places and false at the other places. And if you do dot is null dot sum, what it does is it gives you it groups according to the column, and it tells you like which column is having how many missing values. Or in our case, column 2 has 2 missing values, so it does returns us 2. So this is how we check for the missing values. Another way we use this is like it's just reverse. We use not any function. So what it does, it returns true to us in case the number is not null, and if it is null, it will return as false. It's just opposite of is null, and it's like very intuitive from the name, not any, and is null means whether the number is null. So you can remember it by remembering these names. Now, how do we remove the missing values? So there are certain methods which we adopt to deal with missing values, and one of the methods is like we simply drop in the missing values. So for that, uh, what it does is like it will remove the rows which have missing data. It's not widely used, but yeah, it is one of the ways how to deal with missing data, and there are certain other ways which we'll be learning tomorrow. So how do we deal with this is we use drop any function. If we use the data frame and type dot drop any, it will drop all the rows which had missing values. So in our case, it dropped me all the rows, and now the data frame has only one row. If you want to not remove rows but rather columns, which have nan value. For example, if there is a column, for that column you only have very less, like 20% of the data, and 80% of the data is missing, and that column is not even helpful for you in building the model. So you can simply drop that column out. So you can specify the column name and then use dot drop any function, or you can specify the axis. So you can drop it by axis as well. So if axis one, again, it's like for columns. So this you can execute and check. Now, as I said, dropping the missing values is one way. Another way is like we fill the missing values. We don't drop the rows which have missing values. Rather, we replace it by some values, say, which are for that column, what is the most frequent value or what is the average value. So we replace missing values with such kind of values. So suppose if I want to replace all the null values with a particular number, say here 10 in this case, we just do type the data frame and dot fill in a function. If I run this, you see wherever there was null, it got replaced by the number 10. If you type in anything else, it will replace it by that. So this is how we use fill in a method. Now I'll skip through this. These are like whatever I'm telling you will be like is the most commonly used, and the other things are like lesser used, and so you can read it. So I'm skimming it through. Now we have like more functions and operations which we can perform. So suppose if you have this data frame or the data set, if I print this, so what do we have is so it's df4. We have the product name, we have the order number, and we have the total quantity. Now, suppose if you want a summary of your entire data frame, so how would you get that? So for that, Pandas offers a dot info function, which gives you a detailed summary of the data which you have. So in our case, like if you use df4.info, what you get is the column name. What is the count of the rows which are not null? Here, if you see the not null count is 3 and the total entries are 3. You see there are no null values, and you get the data type of the columns. So if you run this info method, you get the entire idea about your data set. Similarly, we have dot columns and dot keys method, which we've already covered. I'm skipping through it. Other than this, you have dot head and tail function. So what head does is, as the name specified, it returns you the top n rows, and n is the number you specify here, how many rows you want. It returns you the top n rows, and the tail returns you the last n rows. And again, n is the number you specify here. Then here in this case, I've specified the number one, so it returned me the top one row, like the first row. If I specify tail one, it returned me the one row. Now, why do we use it? We use it to understand the data. What is the data set? What kind of values do we have? So we can like simply do df dot head and print the first 5 rows and go through the data to understand it well. Now, if you want to know the size of the data frame, you can again do it, or the number of elements by using dot size method. You want to know the shape, like the number of rows in column, you can use dot shape method. And again, you want the number of rows in a data frame, you can use shape like 0. This is 0, the number of rows, and this is 1, indexed 1, which is the number of columns. Now, suppose if you have your data set and you have many products, but you want to know what are the unique products which I have in this data set. So we can use dot unique function. It will return us all the unique values. So why do we use it? First of all, we get to know what are the unique values for that particular column, and we also get to know whether we have any null values or not. So if we have null values, it would return us NaN as well. So if you want to get the number of unique values, you can get that as well by using NUnique. If you want to get the count of each value, like in a column, so you can check, you can get the count as well. So here we have only one short, one boot, and one back, so it gave us the count. So these are same as like applying the squaring operations and using just lambda functions. You can go through this. We can even sort the values in our data frame using sort values method. So if you specify the column name and you use this method, it will return us the data sorted by the order number. And if you want to reverse sort it, you can set ascending to false. If you want the number in like decreasing order, so you set ascending to false. Now we have certain aggregation methods as well. And for example, if you want to understand our data well, we use dot describe method. So it gives us the entire mathematical summary of our data. So for each column, it will tell you what is the count, what is the unique count, what is the mean for this, what is the standard deviation, what are the quantiles, what is the minimum value, what is the maximum value. And as you do some advanced data analysis, you will find all this information to help very helpful to gather the insights from your data. We can, so here in this example, you see that it has column names here and the metrics here, so it might be difficult to read for some of the few people, so we can like simply use dot transpose, so it just makes the rows as columns and columns as rows, and this becomes more readable to us. Now, if we want the most occurring or the most frequent value for a particular column, we can use dot mode method. If we want a maximum value for a particular column, we can use dot max method. We can specify the column name and dot max. We want to get the minimum value, we use dot min method. So like these are different methods. You can again like these are same as what we covered in Numpy, so you can all go through it. So if you use dot sum, what it will do is all the values, all the row values for this particular column, it will do a sum and it will return you to you. So you see, like a lot of manual things are eliminated. So all these things we'll be using a lot. Now, group by is again most widely and commonly used. So if you have your data set and if you want to suppose group your data set by product name, you see there are repetitive product names. So you have short at multiple places, you have boots at multiple places. If you want to group them by product name, you simply type in dot group by and you specify the column name. And then if you want to perform some operation like based on that you want to access them by product name and you want the mean value like the average orders placed for ankle or like average orders placed for say boots, so you can simply use the mean function. So you see the average quantity like average order placed for bag was 9, and you see the maximum number of orders, or you can see the greatest averages for t-shirts. So by this you can understand like the t-shirt was the most selling item in your shop. So that is how you like understand, and we'll see from the real world data set as well. So like we got the mean, we can even sum, so we can get the total quantities which were sold. Similarly, we have max and min, and it just remains same. So if we want to perform aggregation, like if we want minimum, maximum, and sum for each column, so we can simply do group by and then we can use aggregation property like dot aggregate. So what it does is for each product name, it will aggregate the other column values and it will use these operations which you've specified. Now I'll go to the EDA part. So yeah, okay, let me cover this as well. So suppose if you have multiple data frames, or just for an example, if there are multiple sources for your initial data and you have created multiple data frames, you have made your data ready for building the model, but you have different data frames. So how do we combine those data frames? So for that, we have this concatenation operation. In this case, I have three data frames which have same number of rows and columns. So this is necessary. you should have same. Otherwise, it will like result in NN values. So you use concat method. You simply given your data frame names as a list. So you see it added data frame 1, data frame 2, data frame 3. It combined the data of all these data frames and you get this big data frame. If here what it happened is it placed df1 first, df2 then and then df3. But if you want it to happen like row wise, so it will concatenate row wise. But what happens is it creates multiple columns like of each data frame. And so for the first data frame, you only have values for this. So it will assign like null values to the other columns. It is also required like based on our business requirements in use case, we do these kinds of operations. Now I would skip through this. You can this merge operation is similar to SQL joins which we perform. So if we want all the data, like the entire data from our first data frame and only the data which is common to the first and second data frame, we can use left join. And if we want all the data, entire data from the second data frame, and we want only the common data between data 1 and data 2, we can use right join. Suppose if we have two data frames and we want only the common data in those data frames, so we can use inner join. So here, like I have very well documented everything, and you can go through this and you can go through the official documentation. But just want to keep this session short because I have a visualization to cover as well. So now, I guess, yeah. So we'll be going through, like I said, real world exploratory data analysis to understand whatever we learned till now better. So for that, we are using California housing data sets. It's one of the most commonly used data sets. So for using this and simply downloading this, this data is present at this link and simply downloading that data set. So now this data set, you see, it's a file which is of .csv type. Now, how do we open this file or how do we create a data frame out of this CSV data set? For that, Pandas offers us a function called read underscore CSV. If you do pd.read underscore CSV and you specify your data set, what it does is it accesses the entire CSV data and it creates a data frame out of it. So as I've run this, I have housing.csv present here at my runtime. It got downloaded. So if I do this, then if I run this, it will create a data frame. And how can we check this? We can simply do data.head. So by default, head returns only first 5 rows. Now you never saw this data before and you used dot head and you got access to the first 5 rows. Now you can see like what this data set consists of. So it has this like longitude, latitude. It has uh, median age of the people. It has total number of rooms, total number of bedrooms. What is the population? What is the household? What is the medium income? And what is the location of the house? Like whether it's near to the ocean or not. So just by seeing this, you get a lot of information like what is the data. Now you can print the type of the data. Now suppose one of the most common thing which we use is we perform some analysis on our data set and we want to store it back. We want to store our process data into a CSV file. So for that, we just simply do .to CSV method. We specify the name of the file and we don't want indices to exist. So we just specify it false. If you run this, it will create housing underscore dataset.csv file. So we can also create an Excel file instead of CSV we use .to Excel. If I run this, it will create an Excel file here. You see it got created. So if you check this, you will see Excel file. It got downloaded in my local system. So yeah, this is how you create an Excel file or you store your process data into files. Now we can, similar to how we read CSV data, we can read Excel data as well. So for that, we have read underscore Excel method, like we had a read underscore CSV method. So this is another information. Now we'll perform some EDA. So for performing EDA, I'm using this wine data set. So there's some information about this red wine quality. We are downloading this data set. You see here, I have this data available with me once I use this code. And then we'll create a data frame. So here I created a data frame and I'll use dot head method. So if you run this, you see there are some certain properties, and then we have the quality of that wine. So the higher the number, the better is the quality. So likewise, I access the first five rows. I can access the last five rows for this data set as well. So I'm using the tail function. So what do you observe here is like there's some 198 rows here present. Now you got the data set, you saw the rows, but it's difficult to have the entire summary, right? You want a summary of the entire data set. So for that, we have this dot describe method, or first thing like which we can do is used wine underscore data dot info, and what it will tell us. So it will basically tell us all the columns which we have and all the not null values which we have, and what is the data type of each column. So you see all the values are floating, only the qualities of integer data type. Similarly, you can get the mathematical or the statistical metrics like what is the mean, standard deviation, and what are the quantiles, what is the maximum and minimum value. So you can get all these values, and we'll see how do we like use it, and how do we extract information from it tomorrow. So again, info I've covered, describe I've covered. We check whether our data set has some null values. So for that, as I told you, we use is null.sum. So if we check this, we see that none of the columns have null values. So it's like a cleaned data set. We don't have any null values. Now we want to check like what is the quality, like what kind of quality the most wines have. So if we run value counts, we see that we have mostly good quality wines. So it has a rating 5, and there are 681 wines which have good quality, and we have very lesser wines of say less good quality or bad quality. Like we can even do group by. We can group by the wine data based on, say, if you want to group by the wine data using some certain column values, so we can do that as well. It provides you the entire grouping. I cannot see it right now because it has many rows, so it just dashed them out. So yeah, this was all about pandas, and I hope you've got to learn quite a lot. It was a very extensive notebook, and I'll provide the link so that you can go it in detail because it will take some time to grasp it up. So, am I here till now, and have you all learned something new, which or you've understood it well? Are people there? Am I audible?
Yeah, yes.
Okay, sure. Thank you. Um, so we saw till now we covered NumPy, which is about doing operations on arrays or on data. We saw pandas. How do we um, deal with the data set? How do we download the data in real time? And how do we see the data? What kind of data is it? What missing values do we have? And how do we analyze the data? But doing everything in numerical terms is quite difficult or boring. And it would have been good enough if we could have visualized our data sets, right? If you could have created some plots. So if you have graphs or something or some visual visuals, it becomes easier for you to understand. In order to offer visualization, Python offers us a very powerful library, which is Matplotlib. There are several other libraries called Seaborn, Bokeh, and all have different kinds of features. The Matplotlib is the like first and very easy to use library, which offers you to create some interesting plots, and we'll see what kinds of plots we can create. So can everyone see this Matplotlib notebook? Is it visible? Can somebody confirm it to me? Yes or no?
Yes, Jyoti, continue.
So yeah, Matplotlib, it allows you to create graphs or visualize your data. So in order to visualize your data or use Matplotlib, you need to import it first, as we were doing for Numpy and Pandas, and you use this import matplotlib.pyplot function as PLT. So what it allows you to, it will allow you to use Matplotlib and plot graphs. So PLT again is the most widely used global alias. Here I'm using this percentage Matplotlib inline. So it's a magic function that allows you to create the plots well in your notebooks, in your collab notebooks itself. So first we'll import this. So PyPlot has all the plotting features. So we'll simply start with plotting a simple data. So what we have here is we have our data points for the x-axis, and we have data points for the y-axis. I'm creating an exponentiation graph. So I'm using np.exp function, which does exponentiation of each value for of the x. So now I have both the x data point and y. So SIP graph is basically a 2D, right? So we need two points like the x and the y, and using that we can plot our points. So if we to plot this, we simply use plt.plot. As I say, we are plotting the graph, right? So we use plot.plot method, and we specify the x uh, axis data points and the y axis. We can also tell the title of the graph. So you plotted the graph, but how does somebody else understand like what this graph is about, right? So for that, you can give title to your graph. So you have this dot title method, and here you can specify the title. You can provide labels to even your x-axis and y-axis. So for labeling the x-axis, you have dot x label, and for labeling the y-axis, you have dot y label. You can give your labels here, whatever you want, it should display. So if I run this, I get to plot here, and you see it's a beautiful plot, and it has this X label, Y label, our data points, and they're all connected through lines and the title of the graph. Now I'm going to show you a simple figure to understand you the entire like anatomy of plotting a graph. What are the technical jargons or the terms which we come across. So in order to plot a graph, I'll just zoom in a bit. Um, yeah, so the graph is below components. So it has this title of the graph, and in case you have plotting multiple lines, it will have this legend. So what does this legend tells us is that what is this blue line about, or what is this red line about? We can this line which we get, it's known as line plot, and if we plot a particular point, it's known as scatter plot. We also call it as a marker. Then we have our x-axis label and y-axis label, which you already saw, and we have major text and minor text. Now what is major and minor text? So you see these grid lines. So these grid lines are what helps us to understand or um, plot the values accurately. So for example, this point here, it's 2 on the x-axis and 2 on the y-axis. It just supports your graph. And Wherever we see the numbers present is known as major tick label, and whenever you see a dash, it's known as minor tick label. Or we can even specify the values for minor ticks, and they are small, written in small, and the major ticks they are written in bold and with the larger font. So this is the basic anatomy of like figure or a plot which we make, and there's nothing other than this which lies outside. So we saw how can we plot one graph, but suppose if you want to plot more than one graph in the same figure. So for that we have a function called subplot. So what it does is it allows you to display multiple plots and that too within the same figure. Now suppose if you have your data and you want to plot the data and you want a sinusoidal and a cosine curve. So how can you do this? We simply use plt.subplot method, and what it does takes is it takes number of rows and number of columns and the plot number. So you specify that your plot should have one row and three columns. So your plots will and the plot number to be one. So the first plot will be on the first row and the first column. The second plot will be like if you specify the plot number as 2, it would be in the first row and the second column. And similar to you write in the dot subplot and then you do plt dot plot. Similarly, you again tell the first, like you tell the position of the plot and the plot number. And so if you run this, you see it plotted this subplot and it has three columns and one row, and the first figure is at 1, second assigned one at 2, and the cost one at 3. So we can even like adjust the size of the plot. So suppose if we want a bigger plot, so you see this has the size of 10 comma 8. If we want even bigger, if we want say 15, width to be 15 and height to be 10, so that it's more clearly visible. So if I run this, you'll notice that it is a very big plot and it's more clearly visible to us, right? So using this dot figure and specifying the fixed size, which takes in the width and height of the plot, you can get a more clearer plot. You can even specify the dots per inch. There's a parameter dots per inch, so it gives you a more sharper or clear graph. So it's just another argument which you can give it to the fixed size figure method, similar to the way we are passing fixed size parameter. Now we can even save our graphs, and how do we save them is we use dot save figure function. So if you've plotted a graph and you want to save it, just given currently it's just blank because I've not plotted anything. I'm just giving the figure size and I'm saving this as the name saved figure.png. If I open this, you see I have this save figure.png image available with me. Since this plot is empty, you don't see anything here. It's just a blank canvas with width 8 and height 5. So that's it. Now, as you saw, we already saw we can provide title, access, and labels. Suppose if you want to plot multiple graphs, right? If you want to plot sine, cos, tan all in one picture. So you want that it should be labeled as well, right? So you can differentiate. So we see here we have plot two graphs and we have used different color, like it comes in different colors by default. And we've also provided us label. So here I have used like y1 and y2 as label, which doesn't make any sense, but just for explanation. But if you want to specify like whether it's you can write in like it's sine curve or so you can write as tan curve. So you can infer like what is this what are these blue lines about? What is this displaying? So this is how you can specify this as well. Let me just plot this. So you see here it got changed. It so the blue line says sine curve and this orange line says it's a tan curve. So this is how you can give the legend and how does this legend makes sense? Now, Matplotlib it offers this huge variety of colors. We have these are some commonly used colors codes which I've mentioned, and you can specify even the hex codes, and you can like create. Here I have this example where we've created multiple plots and I've specified the colors, and you see like how beautiful it looks. It has different colors for each plot, specified colors. You can like play along with. You can have different line styles, like you can use solid line. It will look something like this. You can have dash lines. You can use markers, and you can use like different symbols. So here I've specified the list of line markers as well, and you can go through this, like it's quite a lot. You can go through this and whatever you find interesting, you can use it and plot these graphs. So like playing along with the code would make you understand things better and it would make more sense to you. I'll provide the link to this notebook as well. So here, see, I've plotted a graph and I've provided the color as well as the line style. So, for example, the first line style for the red color, it's solid. So you see this solid line here. For the second, it's dotted. So you'll see this dotted line for the blue one. So in case of dashed, you see these are dashed, and this is a colon kind of line style. So you can see basically the names, and it has different markers. So this is how you plot like different plots and figures. You can even add text or annotations to your graph. So, for example, you want to provide an annotation or some explanation here. So what you can do is you can use text method. You can provide the exposition. You can provide the by position. You can provide your text here, and then you can specify the color of the text. If you plot this, it would return us this plot, and it has this annotation with it. So this is how you can provide like some information which is necessary, and you can even annotate some points. So for example, if you want to specify like this is the minimum point, this is the maximum point, you have dot annotate method wherein you type your information, you specify the position of x and y, like which point you want to annotate, and you specify the position at which you want your text to be present. And then you can provide some styling, like here it's like round box. Box should be rounded, and you want the arrow to be something of wedge shape. So you specify the shape, specify the color, and then you see this beautiful graph here. So this is how you can provide, like you can provide more information within your graph, and we do use them quite often. So yeah, this is it. We've covered this all and this all. Yeah, even in subplots, like you can provide titles to individual plots and labels, and you just need to like repeat this. The views to follow, and here I've given the X label, Y label, and title, and it's just all same. You can give different titles, different labels without using for loop. You can specify custom titles for each plot and each labels. So yeah, this is it. Now we have different kinds of plots. Like what we were seeing till now were line plots. There was a line drawn. If you want to specify certain points, right? So how can you do that? For that we have a scatter plot. So what it does it doesn't joins all these points. It displays you the points as the specific point itself or the dot. Then here you see it's some like what do I say? It's like round or it's like a square shaped. You can change the shape. If you want arrow shape, you can use the marker as the symbol. So the marker list is already present. I showed you it was just above. So it has some different shape. So it allows you to create like really interesting, beautiful, and well differentiated graph. Another kind of plot which we have is a bar plot. Now, what does a bar plot signifies? It basically allows you to establish relationship between two variables. So for our taken example, we have fruits, fruit names, and some quantity for those fruits. You can make a bar plot and you can see like which fruit has the least quantity. So here you see it's pineapple, right? It has the lowest bar. Now this is how you make a bar plot. So it will have bar for each property and it allows you to establish, understand like what is the quantity of apples, what is the quantity of orange, all these things. You can again use a different kind of chart which is a pie chart. So pie chart allows you to show the quantity in proportion. So here you see like these orange apple and one more lemon, they have the same proportion, whereas pineapple has the smallest area. So similar to what if you have a piece of cake and you make pieces out of it to distribute among people. So that is what a pie chart is. You can visualize using plt.py function and yeah, we can even like we can play around. We have different parameters. If you so will start executing it or you go through the documentation, you will see if I do shadows equals to true, we see a light shadow, darkest shadow here. Here it's not present above. Yeah, you can notice these differences. Now, the most commonly used plot which we perform like univariate analysis if we want to understand the data well, we use histograms for that. So what histogram does is it allows you to show the frequency distribution. So here you see that orange and pineapple have the highest frequency in this example. So suppose if you were having fruits, a list of fruits, and if you plot a histogram, so it will you'll see that the orange comes two number of times, pineapple comes two number of times, and apple and lemon comes just one number of times. So you see the plot, the bar goes up to 2 and here it goes up to 1. So this is what is fruits like histogram about. And yeah, this is again, suppose if we are plotting a histogram which has 100, it has 100 numbers and we want to see the distribution of data. So you see here it plotted this graph and we see all the values lie between the range -2 to +2 and the most common values lie between the range -1 and 1. So this is how you understand your data. Now we can even create 3D plots using Matplotlib, but I would want you to go and check this out through official documentary. So this was all about Matplotlib. And another like powerful library which we use quite a lot is Seaborn, and it has become quite famous. So I'll just walk you through it, skim through it very fast. So using Seaborn, we can create very nice visualization like different plots. So here I'll not cover the basics, rather I'll just explain you how do we plot these plots. The Seaborn is again used for visualizing or making graphs. So it's very extensive notebook. I'll share the link again, and these are the different kinds of plot which we'll create, and we'll be using them as well. So for creating these graphs, what I'm doing is I'm using a Titanic dataset. So it is a quite famous data set. So I'm importing all the required libraries in the very first step, and then I'll just load my dataset using sns.load dataset. I've loaded Titanic dataset, and these are like fMRI tips and flights. These are like many datasets which I've uh, loaded, and then we'll go through the Titanic dataset. So we use the head method, and so it's just all same. We use head for this, and like just understanding what the flight data is about. What does the tips dataset contain? So Titanic has the details of all the passengers who were traveling through the Titanic ship, and tips is the data about the flowers, and or sorry, tips is the data that is about like what people visit restaurant, the details of the people, and how much tip do they offer. Flights is the data set about the passengers who travel through flights. So we have year, month, and passengers for it. We can go this in detail. Suppose here I'm creating a scatter plot and it's against like two variables. I'm plotting age and fare. So I'm using the dataset Titanic and I'm using the access Seaborn as I imported Seaborn as SNS. I'm using the alias SNS and I'm just using scatterplot function. Takes in your data frame or the data set first, and then your x-axis and then y-axis. These are some other parameters which we can use to make a graph even more understandable and uh, beautiful. So this is what we observe here. Now, what we observe here is if you see the people that are of younger age, they're offering they have the highest fares. So here you see the people aged like middle age 30 to 40, they have the highest fares. And the old age people they travel like less and they have probably very low fares. Now if we use hue, what we can do, we can compare. So if we want to segregate what people are males and what people are females. So we see that the males they have spent quite a lot and they have paid the highest fare, and so it looks females were less and the males were more. So this would make more sense later. So this is how we info from the data. Now we can change the marker as well, as I told you, and we can increase the figure size similar to what we studied in like Matplotlib. So it's all same. And if I skim through this, we have line plots. So we have something called as relational plot. So it does it specifies you some interval or range, and we can plot a line graph or we can plot a scatter graph as well through it. So yeah, it specifies you some interval or range that the most data points lie around. So you see the number of passengers have quite increased a lot as the years pass by. So 1915 there were comparatively less number of passengers traveling through flights, and then there are more number of passengers traveling through flights and as the years pass on. This is the relational plot. Now we'll come through the yeah, these are other examples. Like you can go through this. It's a very extensive notebook with quite a detailed explanation. We can again like plot histograms. So for plotting histograms, we have two functions which are plot and histplot. So if you type in plot and you plot in the age, you see that the people who were traveling in the ship Titanic were aged between 20 to 60. And you see like everything is very intuitive. You just need to give in the plot name, you just need to give in the data frame or the column name, and it's just same for all. So yeah, here are like different kinds of plots which you can go and check in this notebook and explore. And it would be an assignment for you to go to all these notebooks. And one more assignment, which is you need to perform some basic EDA like I showed you on a data set, which I'll share. I'll share the assignment in chat. So this was all about the basic libraries which we use in ML, AI, and data science, which is Numpy, Pandas, Matplotlib. And other than this, I'll be covering TensorFlow, but I'll cover that on day 3. So this is it for today's session, and it has been quite a long. Tomorrow, I'll cover the introduction to ML and all the classical ML algorithms. So I would end the session here and I will share the link to all these notebooks so that you can go through them in detail. So, yeah, I'm stopping now. Is it fine? I guess the time is also.
Sure, sure, sure. Yes, thank you all